Propine, call everyone. Propine, call everyone. Propine, call yaar. Call yaar. Yes, yes, yes. Okay. Can we start now? Yeah, fine. Perfect. Perfect now. So see everyone. Screen share. I'm sharing. Yeah, fine. So pumping lemma. What exactly it is? I hope everything is ready, right? Can you say the date? 37/24. Yeah, good evening. Good evening, everyone. Good evening, everyone. Pumping lemma 37 2000 sorry 20,244 according to hidden 2000 right 20,244 year. I hope we both will stay until 20,244 years. Hidden, you and me both will stay until 20,244 years. I hope so. I hope so. Chalo, chalo, start then. Start everyone. Yeah, now see everyone. Pumping lemma. Observe everyone. Observe everyone. From now onwards, class starting. From now onwards, class starting. Observe everyone. Pumping lemma. Yeah. Priyanti Singh. Yeah, fine, fine. So can we start? Can we start this one? Pumping lemma. What exactly pumping lemma? Right, listen properly. What exactly pumping lemma? Right, we'll see in this class. Right, everything is ready. So what exactly pumping lemma? We'll see in this class. Right, pumping lemma. Everyone listen. Pumping lemma. Pumping lemma. Input is pumping lemma. Input is non-regular. To pumping lemma, we will give input non-regular. It will say output also non-regular. Pumping lemma, input is non-regular. Output also non-regular. It will take non-regular language. It will say non-regular. It will take non-regular language. It will say non-regular. Are you getting? Then people immediately will say one important thing. Then people will say immediately one important thing. That is, sir, it is taking non-regular. It is saying non-regular. So what is so great? It is taking non-regular. It will say non-regular. So what is great? So nothing there. The greatness of the pumping lemma is it will give proof. It will give proof. It will say that you are given non-regular. So answer finally non-regular. It will give the proof. So the purpose of pumping lemma is proving non-regular language as non-regular. The purpose of the pumping lemma is proving a certain language is non-regular. So don't dare to give regular language to pumping lemma. Because pumping lemma meant for proving non-regular. Pumping lemma meant for proving non-regular. If you give regular, right, unnecessary conclusions will come. Please give pumping lemma, right, non-regular language as input. It will say finally non-regular by giving systematic proof. By giving systematic proof. Are you okay with this? Just be comfortable till now. Be comfortable till now. First point, it will be used to prove given language, given non-regular language as non-regular. That is the first point. It will be used. To prove non-regularity. Second point, when you say proof, there are so many ways of proving the theorems. There are so many ways are there, right? So the way what it is following is, it will be used, or it uses proof by contradiction. Pumping lemma uses, when you say proving, it is right, it will be used to prove non-regularity. How it will prove, right? There are so many ways are there to do the proof and all, right? It uses proof by contradiction. 3, it follows pigeonhole principle. Pigeonhole. It uses pigeonhole principle. Just write all these 3 points. It will be used to prove non-regularity. It uses proof by contradiction. It follows pigeonhole principle. These are the 3 points. So in GATE examination, mostly there is a very rare incident questions will come from pumping lemma. It's a very rare incident questions will come from pumping lemma, but 1 or 2 times they asked. 1 or 2 times they asked. That is the reason I am covering. Otherwise, I don't cover. Because you have so many things to study, I don't want to cover unnecessary things. I can cover for my greatness purpose, I can cover. But it will take a lot of time. 13 subject studying is not a normal issue. So just be comfortable with all these points. It will be used to prove non-regularity. It uses proof by contradiction. It follows pigeonhole principle. Someone is saying, right? Okay, I will do, bhaiya, I will do, yaar. Jersey, bhaiya, I will do. Right? In the middle of the story, how can I do? In the middle of the story, how can I do, yaar? Right? Fine. So until now, these points are almost everyone is comfortable. Now observe. Now. Everyone listen. Everyone listen. What is pumping lemma? See this one. What is pumping lemma? Just I'm going to do one small story. Just a series. Everyone listen. Everyone listen. Everyone listen. What is pumping lemma? Careful. One small story I'm going to do. Everyone have to cooperate. Cooperate everyone. Cooperate everyone. See this one. Minimal, see this one. Minimal DFA contain. Minimal DFA contain 5 states. Observe properly. Minimal DFA contain 5 states. Minimal DFA contain 5 states. Please let me know if minimal DFA contain 5 states. Please let me know what is the minimal string it can accept. Minimal DFA contain 5 states. What is the minimal thing? What is the minimal length string it can accept? Make it fast. Minimal DFA contain 5 states. What is the minimal string this DFA can accept? If minimal DFA contain 5 states, what is the minimal string this minimal DFA can accept? I think everyone, epsilon also sometime in this particular DFA, starting state may be final state, who knows? In this particular minimal DFA, starting state may be final state. Starting state may be fine. Epsilon also may accept. Minimal DFA contain 5 states. Minimal DFA contain 5 states means it can accept epsilon also. 0 length. It can accept 0 length. It can accept ARB 1 length. It can accept right double A to double B 2 length. It can accept triple A to triple A depending upon what automata it is. Depending upon what automata it is. Depending upon what automata it is. So 3 length. It may accept. It may accept 4 length. 5 states means it may accept 4 length strings also. Depending upon what purpose you constructed. Minimal DFA contain 5 states. It can accept 0 length also, maybe 1 length also, maybe 2 length also, maybe 3 length also, maybe 4 length also. I want answer from everyone. Will it accept 5 length? I want answer from you. Will it accept 5 length? If minimal DFA contain 5 states, it may accept 0 length, it may accept 1 length, it may accept 2 length, it may accept 3 length, it may accept 4 length. Is there any chance of it will accept 5 length? Is there any chance of it will accept 5 length? Minimal DFA contain 5 states. Is there any chance of it will accept 5 length? Yes, there may be a chance. 6 length, there may be a chance. 7 length, there may be a chance. 8 length, there may be a chance. What I mean to say is, observe everyone. 5 states minimal DFA accepting 5 length or more than 5 length means compulsory guarantee in that automata loop exists. Am I right or not? If minimal DFA contain 5 states, It may accept 0 length, it may accept 1 length, it may accept 2 length, and so on. It may accept 4 length, no problem. If at all anyone say it is accepting 5 length also, it is accepting 5 length also, or more than 5 length also, it is a confirm that loop exists. Loop exists. Now I will conclude one small line. If you have small doubt, you can see this example. If you have small doubt, you can see this example. See this one. See this one. This is the minimal DFA assume. This is the minimal DFA assume. Assume that it is a minimal DFA. Assume that it is a minimal DFA. This minimal DFA contain 4 states. This minimal DFA contain 4 states. If you want, you can observe. If this minimal DFA contain 4 states, if you want, you can observe. If you want, you can observe. This minimal DFA contain 4 states. It can accept, see this one, it can accept 3 length. 4 states minimal DFA accepting 3 length, there is no problem. If at all it is accepting more than 3, means 4 length or more than 4 length. 4 length or more than 4. So let me write now. 4 states. 4 state minimal DFA accepting 4 length string or 5, 6, 7 length. It is accepting 4 length string or more. 4 length string or more. Then minimal DFA contain loop. Then minimal DFA contain loop. Please careful. So 4 states automata can accept without loop 3 only maximum. If it is accepting more than 3, means 4 or more than 4, means there is a loop. Otherwise, how it is possible? 4 states minimal DFA accepting 4 or more length string, then minimal DFA contain loop. Otherwise, not possible. Otherwise, not possible. So listen everyone, this loop area called pumping area. This loop area is called pumping area. This loop area is called pumping area. That is the reason it is called pumping lemma. This loop area is called pumping area. So that is the reason it is called pumping lemma. 4 states minimal DFA accepting 4 length string or more, then that minimal DFA contain loop. That loop is also called as a pumping. That loop is called pumping. That is the reason it is called pumping lemma. Are you okay? Pumping lemma simply saying that pumping required. Pumping lemma simply saying that pumping required. That's it. That's it. 4 states minimal DFA accepting 4 length string or more. Compulsory there is a loop. Compulsory there is a loop. That loop is also called pumping. Looping going on, which is also called as pumping is going on. That is the reason it is called pumping lemma. What is there in that? And one more. When you say loop exists, remember in the pumping lemma means pumping is there, loop is there. Remember before that loop, W. Right? So next one, loop area, X. After loop, Y. Based on the loop, the total string will be divided into 3 parts. W, X, Y. Can anyone help you now? Which area? Can you help you now? Which area having loop? When you confirm loop exists, before loop is W. After loop is Y. Loop area is called X area. Loop area is called X area. Nothing there. X is the place where loop is there. X is the place where loop is there. Now can you help me? When you say that loop is there, listen. When you say that loop is there, you know very well when you say loop, right? When you say loop, everyone know when you say loop, That loop may be repeating one time or two time or three time or any number of time, right? So now listen, everyone. Now listen everyone. Let us assume that given string is, let us assume that given string is, let us assume that given string, this string, the string whichever I return here, that string assume that w, that string is assumed that w. So this w will be divided into three parts. Let us assume that it is a x. Let us assume that it is a y. Let us assume that it is z. So w is equal to your string, right? Your string w is equal to divided into three parts, x, y, z. This is the area where loop is there. This is the area where loop is there. And one more thing, remember, w belongs to L assume. W belongs to L assume. Now W is divided into three parts, X, Y, Z. This is the loop area. Y is the loop area. Before loop is X. After loop is Z. Loop area is Y. When you say loop, that loop can repeat 0 times or many times. Let me write now. I. Right? I. For all I greater than or equal to 0. That means, right, if you repeat that loop 0 times or 1 time, 2 times, right? So remember everyone, x, y power I, z should also belongs to L. Should also belongs to L. When you say loop, that loop can repeat 1 time, can repeat 0 time, can repeat 2 times, any number of times. Then x, y power I, z should also belongs to L. Right? Other than this, nothing there. Someone is saying that 0 possible or not. What 0 possible? What 0? Let me check once again. See this one. Pumping, very simple. Pumping lemma means pumping should be there. Pumping lemma means pumping should be there. That pumping area is Y. Before pumping area X. After pumping Z. So every string belongs to, let us assume that this automata is M. M accepting string W. Let us assume W belongs to L. Now W will be divided into three parts, X, Y, Z. This is the loop area. This is the loop area. So whenever you say this is the loop area if you repeat 0 time, loop area if you repeat 1 time, 2 time, any number of time, it should also belongs to L. In this case, loop is B star, of course, right? 0 times, 1 time, 2 time, and so on. Fine? Is it okay? So let me check once again. X, Y, Z for all X, Y, Z. Right, fine. So now let me ask you one small line now. In automata, listen correctly now. In automata, please observe clearly. In automata, loop is existing already confirmed. If you repeat loop 0 times also, it should belongs to L. If you repeat the loop one time also, it should belongs to L. If you repeat the loop two times also, it belongs to L. Am I right or not? Please let me know clearly. After confirming loop is there. After confirming loop is there. If you repeat the loop 0 times, if you repeat the loop 1 time, if you repeat the loop 2 times, everything should be belongs to L. Will you okay or not? Will you okay or not? 4 states minimal DFA accepting 4 or more length. 4 or more length. That means there is a loop in the automata. When you say loop is there, when you say loop is there, that loop you repeated 0 times, 1 time, 2 time, 3 time, everything should belongs to L. That's it. That's what the pumping lemma is saying. That's what the pumping lemma is saying. After confirming loop, listen, after confirming loop, loop you repeat any number of time. When you confirm the loop, repeat the loop any number of times. 0 time, 1 time, 2 time. It should belongs to L. That's what pumping lemma is saying. Now listen. Now listen everyone. Listen everyone. Listen everyone. Everyone listen. Careful observation. Careful observation. Pumping lemma for finite languages or infinite languages. Please give answer to me. Pumping lemma for finite languages or infinite languages. Pumping lemma means pumping should be there. Can you help me? Pumping lemma for when you say pumping lemma, pumping should be there. It is for finite language or infinite language. It's for infinite language. Because there should be a loop. If loop is not there, there is no concept of pumping lemma. Pumping lemma meant for infinite languages. To prove infinite, right? Infinite language which is non-regular. I want to prove it as non-regular. That's the reason pumping lemma is there. Pumping lemma is used to prove infinite non-regular language as non-regular. When you say finite, where is the concept of loop? If you say finite language, where is the concept of loop? Right? Am I right or not? When you say finite language, where is the concept of loop? Pumping lemma meant for infinite language. Means loop should be there. Now last time I want to ask you, in the minimal DFA, careful everyone, in the minimal DFA, after loop is confirmed, in the minimal DFA, after loop is confirmed, if you repeat that loop 0 times, then also given string belongs to L. If you repeat the loop 1 time, then also given string belongs to L. After confirming the loop, if you repeat the loop 5 times also belongs to L. Now I just want to confirm everyone. Can you see one time? See one time. One time can you see this? Can you see one time? After confirming the loop, can you see this? Can you see this? Can everyone see this? Can you help me now? In this minimal DFA, loop is there or not there? In this minimal DFA, it is a minimal DFA. In this minimal DFA, loop is there or not there? In this minimal DFA, loop is there or not there? Loop is there. If loop is there, listen, if loop is there, repeat the loop 0 times. Repeat the loop 0 times. Then what is the answer? AC belongs to L. This is the L. The language accepted by this automata is L. The language accepted by this automata is L. AC belongs to L. What is the meaning? What is the meaning? Y power 0. This is the Y area. I will write now. I will use another color. Remember everyone, this is X area. This is Y area. This is Z area. So Y repeated 0 time. AC came, belongs to L. Next one. If you repeat the loop one time, ABC also belongs to L. Y power 1. Y repeated one time. Next one. A double BC belongs to L. Y repeated twice. So you want to say that, right? For all, this one, you want to say that for all I greater than or equal to 0, X, Y power I, Z should also belongs to L. After confirming, see this one, after confirming loop is there, repeat the loop any number of times. After confirming loop is there, repeat the loop any number of times. Very simple, yeah, very simple. Pumping lemma means pumping is there. Pumping lemma means pumping there. Based on the pumping, every string of given minimal DFA will be divided into 3 parts. When you say pumping is there, based on the pumping, every string W belongs to L will be divided into 3 parts. X, Y, Z. That Y area is the pumping area. That Y area is the pumping area. So when you say that pumping is there, Y area is the pumping area, that pumping will be done 0 time, then also belongs to L. That pumping area 1 time, then also belongs to L. That pumping area 2 times, then also belongs to L, and so on. Repeat any number of times. This is called pumping lemma. So final question, right? Note pumping lemma for non-regular languages. Second one, pumping lemma for infinite languages. Some students are asking me, listen, some students are asking me, how can you give guarantee loop? Let me check this. Listen, how can you guarantee loop? Everyone listen, how can you give, I'm expecting answer from you. How can you say that loop exists? Let me say this one. 3 states, listen, 3 states minimal DFA, 3 states minimal DFA accepting. 3 states minimal DFA accepting. 3 are more length string. 3 are more length strings. 3 states minimal DFA accepting. 3 are more length strings. Then confirm loop is there. Then loop exists. 3 states minimal DFA accepting 3 or more length string. Then loop exists. When you say loop exists, based on the loop, every string will be divided into 3 parts, X, Y, Z, right? Loop area is Y area. When you say loop area is Y area, when you say that loop area, loop can repeat any number of times. So for all I greater than or equal to 0, X, Y power I, Z should also belongs to L. That's what the pumping lemma is. That's what the pumping lemma is. Yeah, is it okay? Bhaiya, is it okay? This is what pumping lemma. So don't try to give pumping lemma, right? Regular language. Don't give. Someone is saying minimum 3, depending upon problem, right? Let's assume, I'm writing, assume Assume, right, 3 states minimal DFA we have. Assume 3 states minimal DFA we have. And one more, assume that it is accepting 3 or more length strings. Assume I have a 3 states minimal DFA. And one more thing, assume that it is accepting 3 or more length string. Then it's assured that loop exists. When you say loop exists, right, based on the loop, every string will be divided into 3 parts. X, Y, Z. Y area is loop area. So I think, see this one. In the previous problem, I taken 4 states. Priyankit, Priyankit, see, here I took 4 states. Can you see this one? 4 states minimal DFA accepting 4 or more than 4. Then minimal DFA contain loop. Based on the loop, every W will be divided into 3 parts. X, Y, Z. Y area is the loop area. You repeat the loop area any number of times. You repeat the loop area any number of times. Fine? Are you okay? Just remember, see, no one will ask any question. What is the way of asking question? Within a few minutes, I will explain. Within a few minutes, I will explain. What is the way of asking question? Just understand what is pumping lemma. Pumping means pumping. Pumping means pumping. Some people are asking. Some students are asking me, sir, here, right, you are saying pumping lemma follows Pigeon hole principle. Pumping lemma follows Pigeon hole principle. Where, sir? Where? You only say, listen, where it is, see this one. 3 states automata, 3 states automata, 3 states automata without loop. Listen, 3 states automata without loop can accept only 2 length. 3 states automata without loop can accept 2 length only. It is accepting more than 2 length means there is a loop, means some repetition there. It is something like this one, Pigeon hole principle. What is that one? There are, right, n holes are there, but n plus 1 pigeons are there. Definitely one of the hole may contain more than 1 pigeon. Am I right or not? There are n holes are there. There are n holes are there, but n plus 1 pigeons are there. For everyone I given 1, 1, 1, right? N plus 1 pigeons are there. In one of the hole, more than 1 pigeon required. Means loop exists. You want to say that here also loop is there. Loop exists means repetition. Here also same story. Somewhere repetition. That's the meaning of Pigeon hole principle. Right? 3 states automata can accept without loop maximum 2 length only. It is accepting more than 2. Oh, repetition there. Loop there. Similar way, Pigeon hole principle. There are n pigeon holes. N plus 1 pigeons are there. In every pigeon hole, you kept 1, 1. Right? Definitely in one of the pigeon hole, you have to keep more than 1. Exactly same story. Exactly same story. Right? Fine. I think you got the, right, all the important points. All the important points I already explained. I don't want to make complex. I made so easy. Right? Simply, let me read the one by one. Pumping lemma will take non-regular. It will prove that it's a non-regular. It will give proof. It will take non-regular. It will say non-regular. You don't do anything wonder. It will give proof. And the main points of the pumping lemma. It will be used to prove non-regularity. It uses proof by contradiction. It follows Pigeon hole principle. So I started giving some examples. It is one of the example. Careful everyone, it's one of the example. Assume minimal DFA contain 5 states. Assume minimal DFA contain 5 states. And let us assume 2 assumptions here. Assume minimal DFA contain 5 states. Let us assume this minimal DFA accepting 0 length also, 1 length also, 2 length also, 3 length also, 4 length also, 5 length also, 6 also, 7 also, 8 also. Oh, it is accepting more than 4 length. Minimal DFA which contain 5 states accepting 5 also, more than 5 also. By seeing this, I can say loop exists. When you say loop exists, based on that loop, right, your string W can be divided into three parts: X, Y, Z. Before loop is X area, Y area. After loop is Z area. When you say it is a loop, loop can be repeated any number of times. Right? For all I greater than or equal to 0, right? The X, Y power I, Z. Then X, Y power I, Z should also belongs to N. That's it. I given one more example. Assume minimal DFA contain 3 states. It is accepting 3 or more length strings also. Assume that. Then automatically loop concept will come. Based on the loop, I have to divide into 3 parts, everything. And one more conclusion. Pumping lemma for non-regular languages. You cannot give regular. If you give regular, you don't get any advantage. Next one, pumping lemma for infinite languages. Because it is something related to loop. It is for infinite languages. What is minimal DFA is 2 and there is a loop. Someone is saying what is minimal DFA is 2 and loop is there. It is accepting 2 or more than 2. It is accepting 2 or more than 2. Yeah, anyhow, so let's come here. Right, whatever is necessary, those only I'm saying. Everyone observe. See everyone. It's a major one. One small problem I will give, right? One small problem I will give. Accordingly, I will go. See this one. Statement for pumping lemma. Statement for pumping lemma. Everyone observe. All basics are over. Can you see this one? Statement for pumping lemma. Observe properly. Statement for pumping lemma. Careful everyone. Prove L is equal to A power n, B power n, C power n. N is greater than or equal to 1 is non-regular. Can you help me now? Is it non-regular? Conclude this. I will give proof using pumping lemma. Prove L is equal to A power n, B power n, C power n, where n is greater than or equal to 1 is non-regular. Is it non-regular? Everyone, is it non-regular? Prove L is equal to A power n, B power n, C power n, where n is greater than or equal to 1 is non-regular using pumping lemma. Is it non-regular? Fast, yaar. Hello? Hello? Is it non-regular? Prove L is equal to A power n, B power n, C power n, where n is greater than or equal to 1 is non-regular using pumping lemma. Is it non-regular? Let's make it fast. Everyone respond. Everyone respond. Is it non-regular? Prove L is equal to A power n, B power n, C power n, where n is greater than or equal to 1 is non-regular using pumping lemma. Yeah, it is not CFG also. Yes, fine. Is it non-regular? Yes. See, using pumping lemma, see how I am proving. Using pumping lemma, see how I am proving. Listen, using pumping lemma, let us assume that how I am proving. Let us assume that the length of this string, see, A power n, B power n, C power n. Let us assume the length of the string is 3n. N plus n plus n, 3n. The length of the string is 3n. Now observe. Everyone observe. Now everyone observe. What is the pumping lemma will do? First step. Pumping lemma uses proof by contradiction. See the first step of the pumping lemma. Assume L is regular. It uses proof by contradiction. I know it is a non-regular. But see how the pumping lemma follows. Assume L is regular. Can you help me now? If L is regular, definitely there is a minimal DFA. Assume L is non-regular. Definitely there is a minimal DFA or not? Definitely there is a minimal DFA or not? You want to prove non-regular, okay. But pumping lemma uses proof by contradiction. So you will assume L is regular. If L is regular, because of L is regular, there exists minimal DFA. There exists minimal DFA with there exists a minimal DFA with right. Let me try with M states, some number. There exists a minimal DFA with M states. Right, that is the second step. When you say L is regular, automatically there exists a minimal DFA with M states, some number M states. And one more thing is, right, there exists a minimal DFA with M state, that is fine. Now see this one, next one. Let us assume, right, continuation of this one. And also assume W belongs to L. For the given language, because of it is a regular language, assume regular language, you are already assumed regular. And there exists a minimal DFA with M states. And assume that W belongs to L. Everyone listen. And assume that W belongs to L, that is fine. W belongs to L, that is fine. Size of W is greater than, or equal to M. Can anyone help me now? What is W length? It will come within few minutes. I will give. Within few minutes, I will give. Don't worry. Within few minutes, I will give. Don't worry. Assume W belongs to L. Size of W greater than or equal to M. Can you help me now? By seeing this, can you say automata contain loop or not? Assume L is regular. There exists a minimal DFA with M states. When you say it is a regular, automatically minimal DFA there. And also assume that W belongs to L, where size of W greater than or equal to M. Means what is the meaning? This minimal DFA accepting more than M length also. M states automata accepting more than M length string are equal to M length. That means compulsory loop exists. That means loop exists. Size of W greater than or equal to M. Can you help me now? If equal also loop exists or not? 3 states automata accepting 3 length string, then also loop exists. 3 states automata accepting 3 length string, then also loop is exist. Assume L is regular, then automatically there is a minimal DFA with M states. And also assume that W belongs to L, size of W is greater than or equal to M. That means loop exists. Can you help me now? That means loop exists. Okay. Now listen. Let us assume your W is. A power n, B power n, C power n. Everyone listen. Let us assume that your W is A power n, B power n, C power n. Let us assume it is the W. Now see correctly. W is equal to assume that A power n, B power n, C power n. Now see what I am doing. A power n b power n minus 1, b c power n. Now listen everyone now. So it is a confirm that loop already exists. So let us assume, when you say that loop exists, right? Every string belongs to L will be divided into three parts. Let us assume this is X. Let us assume this is Y. Let us assume this is Z. So this is the loop area, right? Y area is the loop area. When you say that there is a loop exists, now based on that loop, every W will be divided into three parts. This is the W divided into three parts. You can divide whatever way you like. X, Y, Z. This Y area is belongs to loop area. Y area belongs to loop area. Now see this one. Everyone observe. Now see this one. Now careful everyone now. Careful everyone. X, Y power I, Z for all I greater than or equal to 0 should also belong to L. Should also belongs to, because of this the loop area which is repeating any number of times, should also belongs to L. Can anyone help me? Can anyone help me? Can anyone help me? See this one. B area, right? I think in the Y, this is going to be A power n, B power n minus 1. This is going to be B power I. This is going to be Z, C power n. Can you help me now? I value 1. If I make I value 1, see what will happen. A power n, B power n minus 1, B power 1 here, C power n, which is going to be A power n, B power n, C power n. It is belongs to L. What is the language L saying? Language L saying that all three people equal. Language L saying that all three people are equal. Now I is equal to 1, it is working. What about I is equal to 2? What about I is equal to 2? I is equal to 2 saying that A power n, B power n minus 1. See this one. B power 2, I value 2, C power n. It became A power n, B power n plus 1, C power n. Unfortunately, it is not belongs to n. Because number of A's equal to number of B's equal to number of C's. Unfortunately, it does not belongs to L. It has to satisfy for everyone. One case fail also fail. Can anyone help I is equal to 2 failing or not? I is equal to 2 fail or not? I is equal to 2 fail or not? If at all it is really possible, you only say one non-regular language you are taken, you created somewhere loop, that loop is repeated any number of times, it should belongs to L. Whenever it is not belongs to L, definitely there is a problem. Can anyone help right? If at all regular, there is a minimal DFA. If at all minimal DFA accepting 5 length string, but a minimal DFA contains 5 states only. Oh, loop exists. Loop exists. If I repeat that loop any number of times, it should be belongs to L. But unfortunately, some cases fail. Can anyone help Some cases fail means our assumption wrong or not. Some cases fail means our assumption wrong or not. This is the assumption. That means our assumption wrong. If at all our assumption is not wrong, it could have been right. So let me write now. For I is equal to 2, this one, which is not belongs to L. So our assumption is wrong. That means L is non-regular. So our assumption is wrong. So L is non-regular. That's it. Very nice story. Assume L is non-regular. If it is non-regular, assume L is regular. Assume L is regular. If it is regular, there exists a DFA with M states. And one more, assume that this minimal DFA accepting W whose length is greater than or equal to M. Oh, loop exists. Whenever loop exists, based on the loop, we can divide our string into three parts. Before loop is X, after loop is Z, loop area is right Y. If you repeat the loop, right? So any number of time, when you say loop, I may repeat whatever way I want. If you repeat the loop, any possibility, right? It should be belongs to L. It should be belongs to L. When I'm doing this, whenever I'm doing, somewhere, right, fail cases are happening. Somewhere fail cases are happening. Oh, right, I think it is not belongs to L. How it is possible? Oh, our assumption is wrong. So L is not regular. No one will ask in the examination prove and all. No one will ask in the examination pumping lemma, prove something like that. No one will ask it. It is used for proving non-regularity. Yeah. How can we repeat the loop whatever way you want? Definitely invalid things will come. Definitely invalid thing will come. Yeah, listen, this is not for a GATE exam. This is for BTech exam purpose. Pumping lemma meant for BTech exam purpose. It is meant for BTech exam purpose. Are you getting? It is meant for BTech exam purpose. It is not for GATE exam. Because of students are asking again and again, that is the reason I am saying. It is meant for, please try to understand, BTech exam purpose. Fine. It's only meant for BTech exam purpose. How they will ask questions in the examination, I will explain. Within a few minutes, I will explain. If everyone is okay, let me know. If everyone is okay, please let me know. Can we move to next? See, you have to prove that. Can anyone help you know? How you know loop exists? It is a very simple story. Other than me, if anyone will teach, they will say big conditions. Other than me, if anyone will teach, they will teach big conditions. They will teach big conditions. Please careful. Can you help me know? How you know loop exists? How you know loop exists? Because of this reason. See, because of this reason. There exists a minimal DFA with M states, and assume also that W belongs to L and the size of W greater than or equal to M. This means loop exists. This means loop exists. When you say loop exists, based on that loop, before loop is X, after loop is Z, loop area is Y. When you say it is a loop area, you repeat the loop any number of time. You repeat the loop any number of time. It should belongs to L. It should belongs to L. Other than this, nothing there. It is a belongs to L. Suppose one case also fail, means your assumption is wrong. One case also fail, your assumption is wrong. So that's it. Right. Okay, fine. Whatever you understood, it's okay. Remember pumping lemma for pumping. Pumping lemma for pumping. Remember this. Now remember. So what examination, what kind of question will come? I will explain. Take the one example. I have to say little bit, I said. Actually, no need to say that also. Actually, no need to say that also. I have to say one little bit of the pumping lemma I done. Now see the first example. Very simple. Very simple. Language L is equal to. Everyone listen. Language L is equal to. Language L is equal to. Observe properly. Language L is equal to. Yeah. Now can I help you now? Listen properly. Listen properly in this. In this language, what is the minimal string? In this language, what is the minimal string? See the way of asking question. In examination, what kind of questions will come? I am going to explain now. In examination, what kind of questions will come? I am going to explain. What is the minimal string in this language? 3. Next minimal. Next minimal. Next minimal. 4. Next minimal. 5. Next minimal. 6. Next minimal. 6. Now listen everyone. Everyone listen. Everyone listen. Everyone listen. Everyone listen. Is it loop area? Is it loop area? Is it loop area? That B star is the loop area. Am I right? That B star is the loop area. Remember, when you confirm loop is there, listen, when you confirm loop is there, 0 times also belongs to L, 1 time also belongs to L, 2 times also belongs to L, 3 times also belongs to L. When you say loop exists, that loop I can repeat any number of times. If at all really minimal DFA possible with the loop, with the help of loop, minimal DFA possible, repeat that loop any number of times. Everything should be belongs to L. If you want, you can check. Loop is 0 time belongs to L. Triple A belongs to L. Loop is 1 time belongs to L. Loop is 2 times belongs to L. Loop is 3 times belongs to L. If really loop there, everyone should be belongs to L. Suppose fake loop is there. Suppose fake loop is there, some people will fail. You only say non-regular language, how minimal DFA possible? If at all non-regular language, how minimal DFA possible? So you are taking non-regular, you are assuming that regular, you are creating one fake minimal DFA. Afterwards, finally, right, something is not belongs to L. So you are proving that, right, our assumption is wrong. So given language is non-regular. In the fake minimal DFA, for every I, it don't work because it's a fake. But true minimal DFA, guaranteed it will work. See, true minimal DFA, 0 times working, 1 time working, 2 times working, 3 times working. Can anyone help you now? Which length string onwards you can give guarantee loop exists? Which length string onwards you can give guarantee in this automata loop exists? For this language, if you create a minimal DFA, from which string onwards you can give guarantee loop exists? I'm repeating once again now. To this problem, if you create a minimal DFA, from which length string onwards you can give guarantee loop exists. So minimal string is a triple A. See, minimal string is a triple A. See this one? Minimal string is a triple A. No loop. Minimal string is a triple A, no loop. Next minimal is, right, I think B's can repeat. After 1A, B's can repeat. So at the 3 length, I cannot confirm loop exists. I think from this place onwards, loop exists. From this place onwards, loop exists. Remember, the minimal string from which you can give guarantee loop exists. For the given language, the minimal string from which place you can give guarantee loop exists. For the given language, For the given language, what is the minimal string to which you can give guarantee loop exists? I think for length or not. That is called a pumping lemma constant. That is called pumping lemma pumping constant. In exam, they will ask you this one, pumping constant. Pumping constant, which is also called as loop guarantee. Minimal string to which loop guarantee. Minimal string to which loop guarantee. I think for length. Which is also called a pumping lemma constant. To this language, to confirm loop, what is the minimal string? See, in the 3-length string, no, when you say minimal string, how loop is possible? When you say minimal string, how loop possible? Afterwards you can see. I think for length onwards, it is a confirm loop exists. Pumping lemma constant is nothing but minimal string where loop guarantee. I think for length. This is the only question what he can ask you. From which length string onwards loop guarantee? Someone is saying, sir, 4-length string loop guarantee, then 5-length also loop guarantee, 6-length also loop guarantee. Yes, 4 correct means 5 also correct, 6 also correct, 7 also correct, but minimal one you select. Minimal string to whom you can give guarantee loop, that is called pumping constant, which is also called minimal pumping constant. Okay, I think answer is 4. I will give one more problem. Can you check? I will go. So if anyone having small doubt, very simple, yeah. For the given language, construct minimal DFA. For the given language, construct minimal DFA. Right? In the minimal DFA, from which length onwards loop exists, check. Right? I will try one more problem. L is equal to, try yourself. L is equal to yeah. Can you try now? Find pumping constant. Find pumping constant. L is equal to 0, 1 star, 0, 1 star, 0, 1 star. Finding pumping constant. Yeah, start writing minimal strings. The minimal string for this language is the minimal string. Minimal string means, remember, loop is not required. Minimal string means, remember, loop not required. I think minimal string 000. No loop required. Minimal string is 000, no loop. Next minimal 0, 1, 0, 0. Next minimal 0, 0, 1, 0. Next minimal 0, 0, 0, 1. So like that, and so on. I think what the answer? Here no loop, here loop is there. From here onwards I can give guarantee loop. Right? I think 4 onwards I can guarantee loop. 4-length string onwards loop guarantee. Four-length string onwards loop guarantee. If anyone having small doubt also, can you see the minimal DFA? Can you see minimal DFA? If anyone having small doubt, 000. I think here may be one possible. Here may be one possible. Without loop 000. With loop, at least one time loop. 0, 1, 0, 0. Loop is there. 0, 0, 1, 0. Loop is there. 0, 0, 0, 1. Loop is there. Next one, 0, 1, 1, 0. Loop is there. So this. Here there is no loop. Find, right? Find pumping constant. Find pumping constant. Fine. Is it okay? Find pumping constant. Is it okay? Is it fine? If it is okay, I can go further. From which place you can give guarantee loop? See, guarantee loop, pumping means loop required. From which place onwards you can give loop guarantee? Which place onwards you can give loop guarantee? Right. Now come here. Now come here. One more interesting thing is going to come. Let's see how many people will give. Let's see one more thing. How many people will give? L is equal to yeah. So I'm giving the answer. See this one. It is a combination of two problems. Try to understand. It is a combination of this problem. See this one. In this one to confirm loop. In this one to confirm loop, 4 length required. In this one to confirm loop. In this one to confirm loop, 1, 2, 3, 4, 5, 6 required. So in any case to confirm, 6 is minimum required. If anyone say 4, he may not agree. See, he may not agree. Because according to second one, 6 are more required. According to first one, 4 are more required. What is the common point? From which place onwards you can give guarantee loop exists? From which place onwards you can give guarantee loop exists? Remember, if anyone say 4, that means that 4 onwards, right? Listen everyone now. 4, right? 4 length is the guarantee. And when 4 guarantee, why not 5 guarantee? Why not 6 guarantee? But remember, right? 4 guarantee doesn't mean that 5 also guarantee here. Are you getting? So here 5, there is no loop. If at all, see this one, 4, right? 4 length is the guarantee of loop. If anyone say 4 length is the guarantee of loop, 4 guarantee means loop, guarantee. 5 also guarantee, but 5 is not guarantee. 5 is not guarantee. Whenever 4 is correct, some people are saying, sir, 4 itself I can give guarantee loop existing. 4 itself loop guarantee existing. 5 also loop guarantee existing. 6 also loop guarantee existing, but 5 is not. In any case, if anyone say 4 are more than 4, it's a confirm that loop exists. It need not be. If I take 5, loop not exist. Are you okay? I can give guarantee 6 are more than 6 loop guarantee. Is it okay? If anyone say 4, that means 4 are more than 4 correct. How 5 correct? You only say. How 5 correct? If anyone say 4 correct, right? 4 correct means 5 also correct, 6 also correct, 7 also. But where 5 correct? How can you give guarantee with 5 loop guarantee? See, remember, pumping, see this one. Pumping constant 4 means from 4 onwards loop guarantee. So 5, there is no loop guarantee. In the second part, 5, there is no loop guarantee. How can you say? From 6 onwards, loop guarantee. Six onwards loop guarantee. If anyone say 5 onwards loop guarantee, if anyone say 5 onwards loop guarantee, you said that 5 onwards loop guarantee. You said like this. Sorry, 4 onwards loop guarantee. You said 5. There is no loop. 5. No loop is there here. See, no loop. Then what is the meaning of guarantee? 6 onwards loop guarantee. So pumping lemma constant. A pumping constant. Pumping lemma constant. A pumping constant is 6. 6 also okay, 7 also okay, 8 also okay, and so on. So minimal one, 6 you have to take. Some people are saying, sir, why don't you take 4? If you take 4, loop guarantee need not be. Because right, 5, there is a one more person, 5. Fundamental property failing. Yeah, I think you are really comfortable. Now I will give one problem. This is the one problem which is given in the previous papers. Only one question is given. In the previous paper, only one question is given. Now I am going to give it now. Now I am going to give it now. See this one. L is equal to a power 2 plus 3k union b power 10 plus 12k, where k greater than or equal to 0. Find pumping lemma constant. Find pumping lemma constant. L is equal to a power 2 plus 3k union b power 10 plus 12k. K greater than or equal to 0. Find pumping lemma constant. Now I want to ask everyone. Can you help me now? In the first language, can you say the length of the strings? In the first language, what is the length of the string? K value 0. In the first language, K value 0, A square, 2 A's. K value 1, 5 A's. K value 2, 8 A's, 11 A's, 14 A's, and so on. But if you see the second language, can you see the second language? I think K value 0, B power 10, 10 B's. Next one, 22 B's. Next one, 2 into 12, 24, 34. Sorry, 30, 34, yeah. 34 plus 12, 46. It is a keep on going. Now, can you see this? Can you see? Some people are asking, sir, how to create the DFA for the first one? Can you see this one? How to create DFA for first one? Observe here. See this one. Observe here. 2, no loop. Everyone observe. 2, no loop. Minimal one, no loop. 5 loop is there. Can you see this one? 5. 2 loop, 2 no loop. So 3, 4, 5. I think this is the case. So until 2, no loop. 2 onwards loop guarantee. So here 3 onwards loop guarantee. In the first one, in the first part, if you say more than 2, if you say more than 2, loop guarantee. Next one, can you come here now? If you observe clearly, second one, I think 10 length. 10 length is minimal. 10 means 11 states maybe. 11 states maybe. 11 states maybe. Let's see this. B, B, B. So 10 times. So 10 B's are completed. 10 B's are completed. So 11th B, 12th B, again 10. So 22. So in the first 10 B's, there is no loop. So here it's a guarantee. See, so here guarantee. Listen everyone, here guarantee. Until 10, no loop. 11 onwards, loop is there. So the common part is one. 3 onwards, loop guarantee. 11 onwards, loop guarantee. If anyone say 4, see one. If anyone say 4, right, he may not agree. He is saying that 3 onwards loop guarantee, but he may not agree 3 onwards. He may say 5 also, he will agree loop exists. He don't agree 5. If you say 3, he will agree, he don't agree. If you say 5, he will agree, but he don't agree. Both should agree. Both should agree. That is the meaning of guarantee. Next one, if I say 9, he will agree, but you don't agree. If I say 10, he will agree, but you don't agree. Because he is saying that until 10, no loop guarantee. If I say 11, he will agree, he will also agree. So I can give the answer. So 11. 11 onwards loop guarantee. In the option 11 is there, okay. Right? If 11 not there, more than 11 you take. See, if 11 is the pumping lemma constant, more than 11 also pumping lemma constant. If 11 is available, select. If 11 is not there, more than 11 also okay. So in the option 24 there, 24 also you can select. 11 or more than 11, anything will be the answer. 11 or more than 11, anything will be the answer. If 11 there, select. If 11 not there, select whichever is bigger. First person saying that 3 onwards loop guarantee. Second person saying that 11 onwards loop guarantee. Combinedly, I can say 11 onwards loop guarantee. Is it okay? Is it okay? See, from here onwards, listen everyone, from here onwards, story required. The story required from here onwards. But if I say directly, pumping and all, you may feel bad. So little bit I said. Little bit. It's not required. One time you read. Pumping lemma means loop required. Loop guarantee what? So that is based on the loop the story is came. So from now here onwards you study. From here onwards you will study. Here, pumping lemma constant. Where this is. From here onwards you study. Only one question is given. Minimal string from which loop is guaranteed. Minimal string from which loop is guaranteed. So I think this problem, here onwards you take care. Pumping lemma constant, here onwards take care. For this problem, pumping lemma. Next problem, it is the first problem. It is the second problem. It is the third problem. It is the fourth problem. That's it. It is a pumping lemma. Is it okay? Bhaiya, is it okay? Someone is saying pumping lemma over. Over bhaiya. Bus, bus, bus karo. Bus. Just whatever theoretical things I said, see, prove, give, don't worry about that. Proof and give, right? Don't worry about that. Not required. It is for infinite language. It is for proving non-regularity. It is for proving non-regularity. It is for infinite language. It uses pigeonhole principle. It is running on proof by contradiction. It is running by proof by contradiction. It uses the pigeonhole principle. Some theoretical things I said, but numerical problem, these only they will ask. Numerical problem, these only they will ask. These only they will ask numerical problem. Fine? Yeah. Over bhaiya. Bhaiya over. Bhaiya over. Ashwini, are you there? Ashwini, are you there? Ashwini, are you there? Every day he killed me. Pumping lemma. Whenever pumping lemma going on, he's not there. Every day he used to say pumping lemma. Every day he will say. Every day he will say pumping lemma. Whenever pumping lemma going on, he is not there. His name is Ashwini Sharma. Whenever I am having peaceful day, he will say, pumping lemma, you are not completed. Whenever I feel today I have peace. Whenever I am feeling, he will come and he will say, pumping lemma not done. Whenever pumping lemma going on, he is no more. Chalo then. Chalo. Yeah, good night then. Good night. Good night, everyone. Good night. Good night, everyone.